Okay, so now we're moving on to the graphing higher degree polynomial problems. And in problems 21 through 24, they want to know the right and left tendencies for each polynomial's graph. You always look at the right first. So on problem 21, we're going to look at the right first. And we consider the leading coefficient. The leading coefficient here is 1. So the leading coefficient is positive. And if the leading coefficient is positive, the right rises. Okay? Now, in order to determine the left tendency, we look at the degree. And the degree here is 3. The degree is odd. So odd stands for, remember, odd equals opposite arrows. So if the right is going up and the degree is odd, the left will go down. Okay, moving on to problem 2. Once again, we look at the right first. And the right, the leading coefficient here is negative. Okay, so that means the right is going to fall. And in the left, we look at the degree for the left tendency, and the degree here is 6. So it's an even degree. And that means that the left is going to have the same tendency as the right, so the left also is going to fall here. Okay, now let's look at problem 23. The leading coefficient is negative, which means the right is going to have a tendency to fall. So the right is going to fall on this polynomial's graph. And then the degree is 5, so it's odd. And remember, odd for opposite, so the right is falling, so the left is going to rise. If the degree is odd, they have opposite arrows. Okay, moving on to 24. The right here, the right tendency, we look at the leading coefficient, which is 1. The leading coefficient is positive, so the right is going to rise. The degree is even, it's 4, so it's going to do the same, have the same tendency as the right, so the left is also going to rise. Okay, so remember, when you're looking at the left and right tendencies, always look at the right first. If the leading coefficient is positive, the right's going to rise. Then if the degree is negative, or odd, the degree is odd, it's going to be an opposite, okay? If the leading coefficient is negative, then the right is going to fall. And if the degree is even, it'll have the same tendency as the right. So you're going to look at the leading coefficient first and then the degree. Okay, let's move on to some actual graphing problems. Okay, so for 25, they give us a polynomial and ask us to graph it. And FF stands for factored form. So they've given us the polynomial in factored form. So it should be pretty easy to find the zeros since they've already factored it for us. And basically, it's whatever makes any one of these sets of parentheses 0. Because if any one of them is 0, when you multiply them by the other, you'll get an f of x value of 0, which technically means it's an x-intercept. So our 0 values here are -1, +2, and +4. Our y-intercept is 8. Okay? And then we need to look at the right and left tendencies. So we look at the leading coefficient. And the leading coefficient is positive because it's 1. Okay, so the right is going to rise. And the degree is 3, so it's odd. So the left is going to have an opposite tendency from the right. So that means the left is going to fall. So now we plot our zeros at -1, 2, and 4. That was at 1, 2, and 4. Okay, y'all, sorry, there were technical difficulties, so if you're seeing this problem 25 twice or partially again, I apologize, but I want to make sure that I get it in here. So, I've told you that this is the factored form of the polynomial they'd like us to graph. So our zeros are any x values that make this set our factors equal to 0. Okay, so in this case it's -1, +2, and +4. Our y-intercept is going to be 8, or 0, 8 in ordered pair form. Our leading coefficient is positive. It's a positive 1. So the right is going to rise. And our degree is odd. So it's going to have the opposite tendency as of the right. And so our left is going to fall. Okay, so we plot our zeros at -1, 2, and 4. And we know we're rising to the right and falling to the left. And our y-intercept is at 0, 8. So now we need to just make our curves between our zeros. So we start up, going up to the right, down, pass through the y-intercept, and back down to the left. Okay? So it should look something like that. Remember, this is a rough sketch. It's not precise or exactly what the graph may look like, but it's just giving us an idea of the pattern. Okay? In the next one, our zeros are going to be +3, -3, 1, and -1. Remember, those are just the x values that make each factor equal to 0. Our y-intercept here is going to be -9, or 0, -9. Our leading coefficient is negative, so our graph is going to fall to the right. Our degree is even, so it's going to, our left tendency is going to be the same as the right, so it's also going to fall to the left. Okay, so we plot our points at +3, +1, -1, and -3. Our y-intercept is -9, which is actually off the graph, so just put it below. And if your y-intercept is not technically on the graph, just graph it as best you can off the graph, and I will not count off. So we're going down to the right and down to the left. So we're going to draw mountains and hills between each point while passing through the y-intercept. Well, this pen is not liking my graphing very much. Sorry, y'all. Let's see if I can try it one more time. Hopefully yours will be much neater than mine on a actual, when you have better control over your pen. Okay, I'm about to give up on it. Okay, there we go, as best you're going to get. Sorry, it's not very nice and precise, but you get the idea. Okay, moving on to 27. Let's see if this one works out better than 26. They have not given us the factor form here in 27, so we need to factor this polynomial out. We can pull out an x from each term, and we're left with x squared minus 5x plus 6. And you can factor the x squared minus 5x plus 6 by picking two numbers that multiply to 6 and add to -5. So that's going to be 3 and 2, and they're both going to be negative. So our factors here are 0, because if you plugged in 0 for x, this whole thing would be 0, 3, and 2. Our y-intercept, if you plugged in 0 for x to get your y-intercept, is going to be 0 also. Okay, our y-intercept is 0. Our leading coefficient is +1, so our leading coefficient is positive. So we are going to, the right is going to rise. Our degree is 3 here, so it's odd. So the left tendency is going to be opposite from the right. So if the right's rising, the left is going to fall. Okay, when we plot our points at 0, 2, and 3, we know we need to go up to the right, pass through our y-intercept, And your graph should look something like that. Okay, moving on to 28. Okay, in 28 we can pull out an x, so we're going to pull out, actually I'm going to pull out a negative x, which leaves you with x squared minus 5x plus 4. And negative x times x, and we come up with two numbers that multiply to 4 and add to negative 5, which is 4 and 1, and they both get negative signs. So our zeros in this case are 0, 4, and 1. And our y-intercept is going to be 0, 0 again. Our leading coefficient is negative 1 here. So our right tendency is going to fall. And our degree in this problem is 3, so it's odd. So our left tendency is going to be opposite from the right, so the left is going to rise. We plot our zeros. And our y-intercept, which is already one of our zeros. And we go ahead and make our curves between our roots. And make sure that we are falling to the right. Oh, look, I made a mistake. Good thing I checked. We have to fall to the right, so we should have gone like this. And risen to the left. So that is the correct sketch of this graph, or polynomial. Okay, let's move on to problem 29. Here, we need to factor this polynomial, and I'm going to choose to factor it by grouping. So I group the first two terms together, and the second two terms together. I pull out the GCF of the first set of parentheses, so I pull out an x squared, and I'm left with x plus 1. And in the second one, I'm going to pull out a negative 1, and again, I'm left with x plus 1. So now these two terms have an x plus 1 in common that I can pull out. So x plus 1 I pull out, and I'm left with x squared minus 1. Now x squared minus 1 is a difference of perfect squares. So I can factor that out to be x plus 1 and x minus 1. So my zeros here are negative 1 and 1. And if you notice, negative 1 is a double root. Okay, so it's going to bounce. When we graph it, it'll bounce. And I'll explain what that means in just a second if you're unaware of it. Our y-intercept is negative 1, 0, negative 1. Okay, our leading coefficient is positive 1, so it's positive. If you look right there, it's positive 1. So our right tendency is going to rise. Our degree is 3, so that's odd. So the left tendency is going to be opposite from the right. So our left tendency is going to go down. I plot my zeros in my y-intercept. So there's 0, negative 1. There's negative 1 and 1. Okay, so we're going to go up to the right. And remember, when we hit negative 1, it's going to bounce. So we start with our tendency up to the right, pass through our y-intercept. And when we hit negative 1, our 0 at negative 1, we have to bounce back down. We don't pass through it, it bounces back down. So if you ever have a double root, it just bounces off that 0 and goes the opposite direction. Okay, so it's really important to remember double root means bounce. Alright, now 29, we have to factor again. So I'm going to pull out the GCF of 2. And I'm left with x cubed minus x squared minus 4 plus 4. Okay, then we can factor by grouping. So I'm left with 2, and I'm going to put the first two terms together, and then the second two terms together. Oop, that should have been an x up there. Okay, then I do the same thing, pull out GCF, so I'm going to pull out an x squared, and I'm left with x minus 1. and then I'm going to pull out a negative 4 of the second set of parentheses, and I'm left with x minus 1 again. Okay, these two terms have x minus 1 in common, so that's what I'm going to pull out. So I'm left with 2 times x minus 1 times x squared minus 4. And you get 2 times x minus 1, and x squared minus 4 is actually a difference of perfect squares, so it's x plus 2 times x minus 2. Now this 2 out front really is a moot point, because it really doesn't affect anything, my zeros. So my zeros are 1, negative 2, and 2 in this case. And my y-intercept is 8, positive 8, so 0, 8. My leading coefficient is 2, so it's positive. So my right tendency will rise in this case. And the degree is 3, so it's odd. So the left tendency is going to be the opposite from the right, so my left tendency is going to fall. I plot my zeros. And I'm going to rise to the right and fall to the left. And my y-intercept is up here at 0, 8. Okay, so you pass through the y-intercept and make sure you only have one mountain or molehill between your zeros. You cannot have a double mountain or a double molehill in between a set of zeros, okay? So that's a sketch of what your graph should look like. All right, let's move on to the last two problems. Okay, in problem 31, they give us a polynomial, and we're supposed to graph a sketch of the polynomial. And they give us a factor. They tell us x plus 2 is a factor. So that's part of it, but we need to find the other factors of this polynomial. And the way we're going to do that is use synthetic division. So if x minus, and we're going to divide this polynomial by one of its factors that they give us, which is x plus 2. So if we were dividing 2x cubed plus 9x squared plus 7x minus 6 by x plus 2 using synthetic division, our a value would be negative 2. Remember, it's the opposite of the inside. So we put negative 2 up here in the left-hand corner. Make sure that our polynomial is in standard form, which it is, with no coefficients, or no terms with a coefficient of 0. So we write out our coefficients 2, 9, 7, and negative 6. We pull down the 2. 2 times negative 2 is negative 4. 9 plus negative 4 is negative 5. 9 plus negative 4 is not negative 5, it's 5. And negative 2 times 5 gives you negative 10. And 7 plus negative 10 is negative 3. And negative 3 times negative 2 is 6. And negative 6 times 6 is 0. So we are left with 2x squared plus 5x minus 3. Okay, so 2x squared plus 5x minus 3 times x plus 2 is partially getting our polynomial in factored form. So the last thing we need to factor out is the 2x squared plus 5x minus 3. And you could use a slip-inside method on this one, but it comes out to be 2x minus 1 times x plus 3 times x plus 2. Okay, so we need to figure out what our zeros are. And our zeros in this case are going to be, if you look closely, what makes this 0, the x value that makes this set of parentheses 0 is 1/2. Because 2 times 1/2 minus 1 is 0. So our first 0 is 1/2. Our second 0 is negative 3. And our last 0 is negative 2. Our y-intercept is at 0, negative 6. So let's go ahead and graph this. Oh, well, we forgot to look at our leading coefficient. Our leading coefficient is positive, so our right tendency is to rise. The degree is odd, so it's going to be the opposite left tendency, so our left tendency is going to be to fall. So we've got our zeros at 1/2, -3, and -2. And our y-intercept at 0, -6. And then we go ahead and rise to the right, pass through our y-intercept, make our mountains between each set of zeros, and that should be a good sketch of what your graph needs to look like. Okay, the last one, doing the same sort of problem. They give us a factor, and we need to finish factoring out this polynomial by using synthetic division. So if x minus 1 is what we're dividing by, using synthetic division, our a value is going to be 1. Got tongue-tied there. Our polynomial is in standard form, and there are no terms with coefficient of 0, so we're good to go. So we write our coefficients out of 1, -2, -5, and 6. We bring down the leading coefficient of 1. 1 times 1 is 1. -2 plus 1 is -1. 1 times -1 is -1. -5 minus 1 is -6. And -6 times 1 is -6. And you're left with 0. So we're left with x squared minus x minus 6 times x minus 1, which is what we are dividing by. We factor out x squared minus 6 x squared minus x minus 6 to be x minus 3 times x plus 2, and then we bring down that x minus 1. So our zeros are 3, -2, and 1, and our y-intercept is at +6. Our leading coefficient is +1, so it's positive, so our right tendency is going to be to rise. Our degree is odd, so our left tendency will be the opposite, which is to fall. So we're rising to the right, falling to the left. Our zeros are at 3, -2, and 1, and our y-intercept is at 0, 6. So we rise to the right and pass through our y-intercepts and fall to the left. Okay, now that is the end of our review video. Good luck on y'all's test tomorrow. Make sure that you go into tutoring or ask your teacher any last minute questions in the morning. And I hope y'all all do great, and I'll see y'all tomorrow. Bye.